Hey guys, Mr. G here. In this video, we're going to take a look at graph transformations for trig functions. Now, in the last marking period, we looked at graph transformations for every kind of function. You name it, quadratic, cubic, all those things. All right. Now we're gonna look at graph transformations for trig functions, specifically sine and cosine. And we're gonna see two types of transformations in this video. All right. Now I have the formulas set up for graph transformations. We have y equals to a times sine of bx and y equals to a times cosine of bx. All right. So we definitely have numbers in the same spot as a and or b. So let's take a look at what each of these two represent. So we have a, specifically the absolute value of it, which represents the amplitude. Now, if you guys recall, the amplitude is the height of the graph from the midline, which is usually at the x-axis, y equals to 0, to the maximum point, or the midline to the minimum point. All right? And then we have the period, which is known as a cycle. And if we recall, we usually look for a degree that represents the period, which also after that degree or radian, the graph starts to repeat itself. All right. So to figure out the period, we take 360 degrees and divide it by the number that's in the same spot as b. Or if we're working in radians, we take 2 pi and divide it by b. They both mean the same exact thing. All right. And then we have quarters. So after we figure out what the period is, we can definitely figure out what the quarters of the trig function are. Now, with quarters, it tells you the distance between each x value. So how do we get from one number to how much do we go from one number to the next? Now, to figure that out, we're going to take the period that we found earlier and divide it by 4 since we're dealing with quarters. All right. Now, before we get into the examples, I definitely want to touch up on the graph for the original trig functions that you guys are seen in the previous video. All right. So if you guys recall, we have y equals to sine of x and y equals to cosine of x. Now, with sine of x, we start off at 0, 0, which is a point on the midline. So a lot of times, the midline for the trig functions are usually at the x-axis, which is y equals to 0. But it may change, but that's for the next video. All right. So we're at the midpoint. We're at the mid. Then we're at a maximum point. So we go from mid to max. Then we go back to mid. Then we go from mid to min, which is a minimum point. And then we go back to midpoint. So the pattern would be, for sine of x, would be mid, max, mid, min, mid. All right? And I have my original x and y coordinates for sine of x. Same thing with cosine. So cosine, we start at 0, 1. So 1 is the maximum. There's the maximum output. So we're at the maximum point. So max to mid, and then mid to min to mid, then mid to max. So we're going from max, mid, min, mid, max. All right. So we're going to use that pattern to help us figure out the graphs with the change of amplitude and or period. All right. So let's go ahead and get started. So in the first example, we have y equals to 2 times sine of x. All right. So what I want to do is I want to figure out what's going to be the amplitude for the graph, what's going to be the period, and how much do we go from one x value to the next. All right. So let's first figure out the amplitude. All right, so the amplitude is usually the number that's in front of the trig function. If we take a look, we see that the coefficient for the trig function is 2. So the amplitude is 2 units. All right. And then we're going to calculate the period. So with the period, we have a number that we have a coefficient for x, but there is no number in front of x, so that means that my b is just going to be a 1. So I'm going to take 360 degrees. Let me just put this over here. Take 360 degrees. We're going to be working in degrees for this video. And I'm going to divide it by 1, and I still get 360 degrees. Perfect. All right. So now let's figure out the quarters. All right, so with the quarters, I take 360 degrees, which was the period, and I divide it by 4. If I divide those two numbers, I should get 90 degrees. So to go from one x value to the next, I go by 90. So we're going from 0 to 90, 90 to 180, 180 to 270, and 270 to 360. Now, if you guys notice, right away in the beginning, I have the x and y table up for you guys. Now this x and y table represents the original coordinates for the parent function, meaning the original graph. We're gonna see, based on having the change of the amplitude and or period, how the x values or the y values change. All right, so let's take a look. So originally, we started at 0, 0 over here, and that is the midpoint, all right? So really, the midpoint doesn't, the 2 in the front doesn't really affect the midpoint. So that means that for my starting point, I'm gonna start at 0, 0. Let me use a different color. All right, now if you take a look, originally we have 90, 1, which the 1 over here for the original function was the maximum point. That means that the amplitude for this one was 1 unit. And now we're going from 1 unit to 2 units. So that means that my height increased to go from 1 to 2, all right? So that means that my maximum point is at 90, 2. So that means I gotta figure out what kind of operation do I do with this 1, 2 to go from 1 to 2. If you guys said multiply, then you're absolutely right. So if I were to multiply this 1 to 2, then I would get 2 as my new output value for 90, 2 for my maximum point, all right? So it's looking like that for each y value, we would multiply by 2. But let's go ahead and keep going with the pattern. So we went from mid to max and we're going to go back to midpoint. So we have 180, 0. And since originally the point was on the midline, the point for over here is going to stay on the same spot because there wasn't really a height around this point. But for 270, there was a height originally. So we're gonna go from mid to minimum. Now my minimum point originally was a -1. So since the amplitude is now 2 units for this graph, is gonna go from -1 to -2. All right? And then we go from min to mid. All right? And then I'm gonna connect my points. So we see we have my graph for y equals to 2 times sine of x. All right, so the height definitely increased. And if we were to analyze the old y values from here, so most of my new y values from here, it seemed that in order to go from 1 to 2, or from -1 to -2, we got to multiply the y values by 2. So we have -1 times 2, which is 2, and, well, this is positive. And then we have -1 times 2, which is going to be now -2. If I were to, and I would do the same thing with the zeros. I would multiply them by 2 as well. But if you multiply a number by 0, still stays at 0. So that's why when we graph this when we graph this without having to use the x and y table, we see that the minimum points, the output values for the minimum points, really didn't change anything. It stayed in the same exact spot on the x-axis, all right? So for each y value, we multiply by 2. So that means that if we have a number in front of the whole trig function, then we were to multiply the y values by that number. So if you want, we can write this down for the amplitude. We would multiply the y values by whatever a is, all right? Okay, so now that we got our graph for example 1, we're gonna move on to the next problem, all right? So for this one, we have, instead of having a coefficient in front of the trig function, we actually have a coefficient only in front of x, which is on the same spot as b. So we're going to see a change in period. All right, so first off, let's go ahead and label the amplitude, the period, and the quarters. So we have the amplitude. So since I don't have a number in front of the whole trig function, there's no number in the same spot as a, that means that my amplitude is gonna be 1 unit. All right, and then we have the period. So for the period, we take 360 degrees and divide it by the number that's in the same spot as b, which is 2. So 360 divided by 2, I get 180. So that means that after 180, the graph is going to start to repeat the pattern for a cosine, all right? And then I'm going to figure out the quarters, all right? So for the quarters, I have the period, which is 180, and I divide that by 4. And if I were to divide those two numbers, I should get 45 degrees. All right? So to go from one x value to the next, I'm going to go by 45s. So we're going from 0 to 45. 45 to 90, 90 to 180, and 180 to 90 to 135. My apologies. Let me get my whiteout. We're going, for some reason, my brain was still stuck at 90, 190, 180, 270, 360. But I'm going to correct that. So from 90 to 135, and then 135 to 180 degrees. I'm going to stop right there, all right? So if we take a look at the x values, this is the original table for cosine of x, all right? But now, if we take a look at the x values on the graph, we see that we went from 0 to 360 to 0 to 180 degrees. So we definitely do see the x went down. And let's try to figure out what operation would we do to the x values if we were to have a number in front of x. So we went from, we stayed at 0, 0, but then we went from 90 to 45, 180 to 90, 270 to 135, and 360 to 180. So what we could do, what happened to the numbers is that it reduced by a half, or in other words, divide by 2. All right? So for each x value, we would have divided by 2. And the y's would stay the same since the amplitude is still 1 unit. So I'm going to go ahead and make my graph. And I'm going to use the pattern from the original cosine function to get my new cosine function. So we're at max. We started off at max. So we have 0, 1. We're still at 0, 1. All right? And then we're going from max to mid. So originally we were at 90, 0. So now we're going to be at 45, 0. So if I were to divide 90 by 2, I would get 45. And then we're going to go from mid to min. Oh, should be up here. That's 2. All right. And then we have mid to min to mid. 135, 0. Then we're at mid to max. And I'm going to connect my points. So the x values definitely decreased for cosine of 2 of x. So what happened was that each of the x values were divided by 2. Now, if you guys notice, I'm not really solely relying on the x and y table to help get my new graph for whatever trig function I'm given. What I'm really using is kind of the pattern from the original to the new one and the information that I'm given over here. But if you must insist, if you feel that using an x and y table helps you get the new graph, then use it by any means. All right, so now we're gonna move on to the last two problems. So in the third example, we have y equals to 1/2 times cosine of 3x. So let's go ahead and figure out my 3 pieces of information, starting with the amplitude. All right, so with the amplitude, it would be the number in front of the whole trig function, which is 1/2. All right, so that means that my amplitude is 1/2 units, and for my y values, I would multiply by 1/2. All right, and then we have the cosine. So we have cosine of 3x. So now I'm going to figure out my period. So for the period, I take 360 degrees and divide it by 3. And when I divide those two numbers, I get 120 degrees. All right? So that means we went from 360 as a period to 120 degrees, and it seemed that it reduced by 3. So I would divide each x value by 3. All right? So now let's go ahead and figure out the, quarters. All right? So with the quarters, I'm going to take my period, which is 120, divided by 4. And when I divide those two numbers, I should get 30 degrees. All right. So to get from one x value to the next, I'm gonna go by 30. So we go from 0 to 30, 30 to 60, 60 to 90, and 90 to 120. All right. All right. So what we're gonna do is we're going to get my new graph for cosine of x by using the pattern from the original. So remember, the pattern is max, mid, min, mid, max. So we're gonna do the same thing for this one. So the original point was 0, 1, which is the maximum point, and now the amplitude is reduced to 1/2. My new point for this one would be 0, 1/2. So it's gonna be somewhere in between 0 to 1. All right. So now we're going from max to mid. So there's not really any change in the y value, but for the x value, we definitely see that. Because now we're going from 90 to 30. The x value reduced from 90 to 30. All right, so we're at max, mid, min. And I'm at negative 1/2, then to mid, and then to max. All right, connect my points. So we see, if we compare the original graph to the new graph, we see that the height reduced by 1/2, and the width, the horizontal width, compressed from 360 to 120. So each x value we divided by 3 to get these x values, and each y value we multiply by 1/2. All right. Okay, so here we have our new graph for the third example. So now we're going to move on to the final example. Now we're still going to use 3 and 1/2, but now their positions are going to be changed. So the 3 is going to be in the front, and the 1/2 is going to be in front of x. All right, so first off, let's go ahead and figure out my 3 pieces of information. So let's figure out the amplitude. I'm going to call this amp. I'm amped up for this problem. All right. So if we take a look, we see that there's a 3 in front in the same spot as A, so my amplitude is 3 units. And then we have the period. Now at the period, we have half in the same spot as B. So I'm gonna take 360 and divide it to 1/2. All right? So if we take a look, we're dividing a whole number by a fraction. So that means that I have to use a certain kind of technique to change the setup because I can't divide by a fraction. All right, so what I would do is I would do the keep, change, flip. Keep this, change this into a multiplication, and flip this half into a 2. So I would read this now as 360 times 2. All right, so if I were to do the calculations, I would end up with 720 degrees as my period. All right, so we went from 360 degrees to 720 degrees. All right, now to figure out the quarters, to get from one x value to the next, I'm gonna take 720 divided by 4. Can you guys see that? Perfect. We make the 720 more visible. And once I divide those two numbers, I end up with 180 degrees. So to get from one x value to the next, I'm going by 180. So we start at 0, then we go from 0 to 180, 180 to 360, 360 to 540, then 540 to 720, all right? So I added each x value to 180 to get these values, all right? So if we were to take a look, we see that originally we went from 0 to 360 to now 0 to 720. So the x values definitely increased by a lot. And it definitely increased because we divided a number by halves. And if you divide a number by a fraction, then it actually increases the number by a lot. So for the x values, I would divide by a half, but if you recall, it could also be known as multiplied by 2. So it would be x times 2. They both mean the same thing, all right? And then for the y values, I would multiply by 3, all right? So let's go ahead and get my new graph for 3 sine of 1/2 x by using the pattern, all right? So for the pattern, we have mid to max to mid to min to mid. Min to mid. All right, so I'm going to use the same pattern. So we go from mid to max. Now originally, my max is at 1, and since my amplitude is now 3 units, I'm going to go up by 3. All right, and then max to mid, then mid to min. And originally my minimum was a -1, and now since my amplitude is 3, it's gonna go from -1 all the way to -3. And then to mid. So we got mid, max, mid, min, mid. All right? And I'm gonna go ahead and connect my points. So there's a few ways to go about graphing a trig function. Using an x and y table can definitely be helpful since we're pretty much used to making an x and y table. And if we were to make an x and y table originally and use the operations, you would multiply each x, y value by 3. And you would divide each x value by a half, or in this case, multiply by 2. So I'm gonna divide by half. Or you can say 0.5. All right? Or we can use the pattern from the original trig function, so sine and cosine, to get my new graphs without really having to use an x and y table. And what we would use is the 3 pieces of information. All right? If you guys still have any questions, feel free to email me. I hope you guys have a wonderful and fantastic day.